Hi. All right, well, based on a lot of popular demand, I'm going to do problems 4 and 6 out of the homework in this video. So number 4 was this one showing 3 vectors, A, B, and C, that are on a grid. And it says vectors A, B, and C are shown in the figure. Draw vectors D and E, where D is A plus B and E is A plus C. And one of the issues was that where they put the picture in the book didn't quite match up with where the question was. So you may have had trouble finding it. This is the picture they were looking for. And they were using the same picture for 3 different problems. Okay, so first, let's say I want to draw a vector D. D is supposed to be equal to A plus B. Okay, well, A is this one right here that looks like it goes to the right by 1, 2, 3, 4, and up by 1, 2, 3, 4. Okay, so let me lay that out. First do A1. You can see that it's gone right by 4 and up by 4. And then B has to go up by 3 and left by 1. I see that I haven't given myself enough room. So I'm going to move that vector so that I do have enough room to fit it in. And I'll still make it line up with the grid so that's a little bit easier to deal with. So there's vector A. And I'm going to add to it B. B, I have to start. So basically this vector is saying there's a story of I've walked some distance diagonally, which is equivalent to having gone to the right by 4 and up by 4. So now I'm going to go up by 3, 1, 2, 3, and then left by 1, right there. That's vector B. Okay, and then the result of that vector is what I would get if I would go straight along that diagonal right there. So that is vector D that the question is looking for. The result of if I had gone along those 2 vectors is the same as if I had just walked diagonally along that. That's what D is. All right, that was part A. Part B, well, no, sorry. Now I need E equals A plus C. So E vector is supposed to be A plus C. So A, same thing. I still want to go to the right by 4 and up by 4. So start there and add 1, 2, 3, 4, 1, 2, 3, 4. That's the same as going along that diagonal. And then C is down by 3 and across by 1. So 1, 2, 3, 1. There's C. So A plus C is what I get if I go along that diagonal that goes straight there, which is equivalent to having gone 1, 2, 3, 4, 5 to the right and up by 1. So that's vector E. Okay, so that gave me those 2 sums. Then part B asks a slightly funny looking question. Show that A plus B is the same thing as B plus A. All right, it might seem like there's hardly a question, but it's possible that if you walk one direction and then walk along one vector and then another vector, that you don't end up in the same place if you flip the order around and go the other one first and then the other one. So let's find out. Well, A plus B, I've already figured that out. That's what D is. So let me make a copy of that. So I'll show A plus B. And say I start right here and go 1, 2, 3, 4, up 1, 2, 3, 4. There's A. And then B is up 3 over 1, 1, 2, 3 over 1. So that's where I end up if I do A plus B. And now I'll show in green what it looks like if I do B first and then A. So B first is go up by 3, 1, 2, 3, and then to the left by 1. And then I do A, which is to the right 4 over 4. 1, 2, 3, 4, 1, 2, 3, 4. And you end up right there. So this green path is B plus A, and the black one that I've drawn is A plus B. And you can see that you end up in the same place, so that is a proof that it doesn't matter what order you add the vectors in, or it doesn't matter what order you do the walking in, you still end up in the same place. That's the point of that question. All right, and so for all three of those, the way that we did that is by laying out the vectors and thinking about what were the components. For A, left 4, up 4. For B, left 1, up 3. And for C, down 3, right 1. Okay, now let's move on to problem 6. In the drawing, the vector sum of forces A plus B plus C. What is the vector sum of the forces if each grid square is 2 newtons on a side? Okay, so basically it's asking what's A plus B plus C, and then translate that into numbers for a force. Okay, so A looks like it is 1, 2, 3 to the right, 1, 2, 3, 4 up. So let me draw that. 1, 2, 3, and 1, 2, 3, 4. So there's my A. That's what I get if I first do A. Now plus B. B is 1, 2, 3, 4 down. 1, 2, 3, 4 down. And then C is 2 to the left. 1, 2. All right, where do I end up if I follow along that path? I go A, then B, then C. I end up right there, which is just a little bit to the right of where I started from, in red. All right, so what's the length of that vector? It's 2, because the problem says that we're using the grid to represent 2 newtons. So that little vector to the right represents 2 newtons to the right. So the result of those 4 forces is the same as if I just had one force pulling to the right with a magnitude of 2 newtons. And that's it.